Hello, welcome to IGNOU's classroom. You are here on the course for Information Systems for Managers, and in this video we'll be talking about data warehousing and data mining. So this is part of Unit 13. It is a little bit big. There are a little bit concepts that we have to cover over here. It's kind of like a continuation to what we learned in the last video about databases and database resource managements. So a quick disclaimer, this is going to be a bit long, but I assure you it will be worth it. So with this video, actually, on this unit, actually, the data warehousing and data mining unit of MMPC, it actually highlights the importance of building an enterprise data warehouse, as well as the types of data which is contained in a data warehouse, and the design decisions involved in data warehouse designing, the architecture of such a warehouse, what are its various components, and things like that. Okay, so we will talk about the need for data warehousing as well as data mining, the operational as well as informational databases, what data warehousing is, what is a data warehouse schema, what are the various schemas, what is metadata, what is OLAP, that is online analytical processing, data visualization, as well as data mining. So let's get started. So what is a data warehouse? A warehouse is we talked about this even in the last session. It is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process according to Bill Inman. So this is an example. Over here, what you can see is an example of a real-world warehouse. Okay. Now think about this thing. Okay. But whatever is stored is not your cardboard boxes or anything like that. What is stored is data in various forms and formats and things like that. Okay, so that is the entire concept of what a data warehouse is. So the architecture of a data warehouse is like this. Okay, so data comes in. It could be operational data or external data. It comes in, and all the input coming in data actually is what first encounters the load manager. Okay, and the load manager converts this data, okay, and gives it, or you can say it directs this data that is coming in to the warehouse manager. So the warehouse manager actually is in charge of creating the summary information, detailed information, and processing of this metadata and things like that. So the data warehouse manager actually gets data and transforms it into information, and it is provided to query manager. So the query manager is where the data miners and OLAP tools will hit. Okay, so that is where we programmers will hit. Okay, we with our SQL queries or no SQL queries, maybe Python scripts and things like that, we will be hitting the query manager, and the query manager will connect with the warehouse manager in order to get the information which will be used for the decision making. Okay, so this is the basic architecture, the simplest architecture for a data warehouse. So when we talk about designing this data warehouse, we have to take into consideration the time span which is permissible for queries to hit and return proper results, the granularity, the dimensionality, aggregation, partitioning, and things like that. So when we talk about data warehouse management or a data warehousing, two terms, okay, facts and dimensions, are something which none of us can escape from. Okay, especially when you talk about data data part of it. So even like I had mentioned earlier about the Power BI course, I did get a few requests, but I'm still waiting because I do not want to make a course on Power BI at the cost of MMPC series. That is why I'm waiting. But if in case you are interested in such business intelligence data visualization tools also, you need to understand about these facts and dimensions. Okay, these are the fundamental elements that define a data warehouse. So facts are the transactions that have occurred at some point in the past. It's a fact that it has happened. Okay, and they are unlikely to change also in the future. They are measurable events which are related to the functional area covered by a data warehouse, and these fact tables are the core tables of a data warehouse. Coming to dimensions, on the other hand, they are collections of reference information about the facts in a data warehouse. And dimensions will categorize and describe the facts which are recorded in a data warehouse to provide meaningful, categorized, and descriptive answers to business questions. The simplest way in which you can think of facts and dimensions is you go to any grocery store, okay, any hypermarket, you get a bill, right? So in the bill, what all things will be there? Or you will have the item code, okay, item name, then you will have the quantity and the price associated with it, and then at the end you will have your total amounts, GST and things like that, right? That is a representation of your fact. Okay, so that is a fact table. It is a order informations get stored as fact tables. Okay, now when you go to return the item, how do they know more details about the product? It's not like you what you can say, it's not like you bought a Samsung phone and then when you go to return it, it doesn't magically change it in an iPhone, right? Unless you pay extra for it. No, how do they know? How do they know that you're not cheating? Right? Or how do they know that, okay, it is mentioned over here, sari worth 5,000 rupees, okay, but you might have taken some other sari and went, which is not even in the list over there. How do they know? Sari, of course, there's no barcode scanner. Which other examples? So, yeah, the phone itself, let's say, okay. So how do they know these things? So each order will definitely have multiple, each order ID will have multiple, what you can say, data in it, right? Multiple records will be there associated with each order ID, which will have the product code. Now that product code will be linked to a dimension table called products. Okay, in that also the key, the linkage key will be the product code there also. That product code will have, okay, this is the item, maybe it is a Samsung Galaxy, okay, and this is the manufacturer, this is the price, this is the stock available, this is the color, this is the make, and things like that. Lots and lots of information might be there, right? So that is a dimension table. Similarly, so this single fact table, okay, your order ID related details will have links to multiple product tables. Electronics will be there, right? When you go to a hypermarket, it's not just grocery that you buy. You may buy grocery, you might buy dresses, you might dress or deodorants or beauty products, you might buy electronic items, you might buy crockery, right? Plates, dishes, you might go for cleaning utensils, god knows, right? Depending upon the selection of the supermarket, you might buy lots and lots of things, and each of those different things will most probably be categorized into multiple product tables. Okay, so those are all dimensions. So that is the easiest example I could think of to make you understand about facts and dimensions. So that is the thing. So facts actually can be analyzed in different ways by cross-referencing these facts with the different reference informations. And while we are designing the data warehouse, it is very common to create the dimension tables first and then create fact tables by relating them to the dimension tables through foreign keys. So for this reason, we have various classifications of dimension tables. So that is first we need to talk about the data warehouse schema to understand how the tables or the classification happens. So schema is nothing but a logical description of the entire database. Um, it is like if you remember the network topologies, we had the star schema, the bus ring, hybrid tree and all. It defines how the data points or at that time the network nodes were arranged. Similar to that only here, instead of the network nodes, here we'll be arranging data tables. That's it. Okay, schema. So it includes the name and the description of records of all record types, including associated data items and aggregates. And much like a database, a data warehouse also requires to maintain a schema. A database uses a relational model, while data warehouse uses schemas like star, snowflake, fact, constellation, okay, fact, constellation, and things like that. So we look at them a little detail. So in case you are interested in things like data visualization or business intelligence tools like Power BI or Tableau, ThoughtSpot, things like that, this is I would say a very useful information, especially if you are going and starting it up, you're thinking of starting it and all, starting to learn and all. This information would be quite helpful to you. So this is an example of a star schema. So each dimension in this star schema can be represented by will only be having one dimensional table, and these dimensional tables will have a set of attributes. Like for example, if it is a phone, we'll have the manufacturer name, the color, the battery capacity, the charging capacity, things like that, and screen size. All those things are attributes. Now, there will be a fact table at the center which will contain the keys to each of these dimensional tables. And the fact table will also contain its own attributes, just like how our order ID or the bill was linked to the products table. Just like that, we will have in star schema. Snowflake schema, what happens is that in snowflake schema, think of it like a snowflake. Okay, so fact table at the center, Okay, it will be linked to multiple dimensional tables, but those dimension tables may have its own other sub-dimensional tables. Okay, so that becomes a snowflake schema. So why there is because when you those dimensional tables may have had normalization applied to them, and that split the data into additional tables. So due to this normalization in the snowflake schema, what happens is that redundancy gets reduced, and therefore it becomes very easy to maintain as well as save storage space, which is very essential because we all know the ease at which our what you can say storage gets run out, right? So think about corporates. It's very difficult to maintain storage, and that is a very challenging proposition also, which requires a lot of brainstorming and optimizations and things like that to be adopted in order to save space. Is very database storage capacity is very important, and it costs also, costs a fortune to, because it's not 1 GB or 2 GB of data you're talking about for organizations, right? That's the reason. So coming to the fact constellation schema. So a fact constellation actually will have multiple fact tables, and therefore it is also known as a galaxy schema. It is possible to share dimensional tables between fact tables as well. Coming to metadata is another term which you will commonly hear in association with data and data warehousing. So metadata in a data warehouse is similar to the data dictionary in which we saw in the what you can say in the database and the previous video. So metadata also stores data about data in the data warehouse. Okay, so like the help manual, it's like the help manual for data warehouse metadata. Okay, and metadata in a data warehouse may be operational metadata, extraction and transformation metadata, or end user metadata. Warehouse metadata is actually not very different in kind from ordinary database metadata, although it is actually versioned in order to permit historical analysis. So why exactly is this metadata important? Why are we talking about metadata? Well, the reason being metadata actually acts as the glue which connects all parts of the data warehouse. It provides information about the contents and structure to developers and opens the door to the end users and makes the contents recognizable in their own terms. So in case you like how this video is going, you find it useful and you haven't subscribed, please consider subscribing as well as sharing about us with your friend circle and spread the word about our channel, because in that case I will be able to reach more students like you and help them out as well. So please, humble request from you all, kindly consider subscribing, at least sharing about our channel. Coming to online analytical processing, or OLAP. Online analytical processing is actually a type of application which allows interactive analysis of data. It enables data analysts, to identify business strengths as well as weaknesses, business trends that are, and the underlying causes of those trends. It provides an insight into the business through interactive analysis of the different views of business information, which has been built up from raw operating data and which reflects the business users' understanding of the business. The OLAP application layer is actually accessed via a front-end query tool which uses tables and charts to drill down or navigate through dimensional data or aggregated measures. The key features of such a processing system include multi-dimensional views of data, calculation intensive capabilities, as well as time intelligence. Coming to data visualization, if you have gone through, definitely you would have gone through, you're in second semester right now, MMPC 5, that is a quantitative aptitude for managerial decisions. The very first block we studied about data, its collection as well as presentation, right? The various kinds of charts and bar graphs and things like that, histograms and whatnot. So how do we do that? Rarely these days, I don't think rarely, nobody right now sits with a chart paper like you did in school, like we all did in school, plotting data points on a green or a red chart graph paper with scale and pencil. We all have tools. So the tools which I mentioned a little bit earlier, like Power BI, Tableau, ThoughtSpot, even Excel, Microsoft Excel. Actually, Power BI, Power Tools were developed as an extension to Excel, Microsoft Excel only. Even Google also has its own data visualization tools. So these are the tools which we use. These computer applications are what we use right now to do these visualizations, data visualizations, creating bar graphs or pictograms or scatter plots or whatever it is. Right, so data visualization applications render large quantities of data in the form of charts or graphical indicators, scorecards, dashboards, and animations and virtual reality environments and all those things. By automating this fundamental aspect of data analysis, it helps information users to identify the trends as well as patterns in data which are often not apparent in traditional tabular representations. And managers actually have found these applications very effective for viewing business activity at a glance. So what exactly makes a good visualization? It should be effective, right? It should be easy to interpret. It should be accurate, because you don't want to be looking at a graph which is not accurate, which is not showing us the correct picture. It definitely, aesthetics plays an important aspect. It must not offend viewers senses. It should be pleasing to look at. The color combinations, the line weights, all those things, the font selection, everything should be pleasing to the eye. Otherwise people won't be so happy to look at it and spend time with it. And it should also be adaptable to adjust to serve multiple needs. Coming to data mining is the exploration and analysis by automatic or semi-automatic means of large quantities of data in order to discover meaningful patterns and rules. It needs substantial computing power, parallel hardware databases, and other very powerful components, which makes it a bit costly. And with all those things, only data organizations can afford to do data mining. So data mining is actually not something which comes in cheap. So comparing data mining versus OLAP, which are both used to, what you can say, deal with data. Data mining is a multi-dimensional analysis having a large number of dimensions and generally deals with the summary of data and used for insights and predictions. Okay, having a bottom-up approach and which is discovery driven. Okay, but OLAP is online analytical processing. It has limited number of dimensions and deals with detailed transactional level data and is usually used for analysis of past data. Therefore, it is a top-down approach and it is query driven, but it is widely used than data mining because of the whole accessibility and accessibility stuff. The various techniques which we use for data mining include cluster detections, decision trees, memory-based reasoning, link analysis, rule induction, associate rule discovery, outlier detection and analysis, neural networks, genetic algorithms, sequential pattern discovery, and things like that. So generally data mining gets applied in areas like customer segmentation, market basket analysis, risk management, fraud detections, delinquency tracking, and demand predictions. And how we do data mining is, first we define the business objectives, we prepare the data, that is we clean them up and things like that, perform the data mining on it, evaluate the result, we'll present the discoveries and ensure the usage of those discoveries. That is the whole concept of, or the whole process behind these data mining. So the data mining tools, how we select those data mining tools is based on data access, data selection, sensitivity, data visualization which we hope to achieve, the extensibility, performance, scalability, openness, the different various suites of algorithms like random forest or decision tree or linear regression, things like that, algorithms, as well as multi-technique support. Now, the reason why organizations go for this data mining, even though it doesn't come cheap, is because it helps companies gather reliable information. It is, compared to its effectiveness, it is efficient, it is cost effective compared to the other data applications. It helps businesses make profitable production as well as operational adjustments and uses both new as well as legacy systems. It helps businesses make informed decisions and detect credit risks and fraud. It helps data scientists easily analyze enormous amounts of data quickly, and data scientists can use this information to detect fraud, build risk models, and improve product safety. It helps data scientists to quickly initiate automated predictions of behaviors and trends as well as discover hidden patterns. Data mining, though it offers a lot of benefits, also comes with drawbacks. Like many of these data analytics tools are quite complex as well as challenging to use, and these data scientists need the right training to use the tools effectively. And while we are talking about the tools, different ones might work with varying types of data mining depending upon the algorithms they employ. So data analysts must be sure to choose the correct tools. Data mining techniques are not infallible. There is always a risk that the information isn't entirely accurate, and so this obstacle is especially relevant when there is lack of diversity in the dataset. Companies can potentially sell the customer data they have gleaned to other businesses and organizations, which could actually be a privacy concern. And data mining requires large databases, which makes this process very hard to manage as well. So I hope you got an overall idea about data warehousing and data mining by the end of this video. Thank you so much for sticking with me. In the next video, we'll talk about about artificial intelligence and decision support systems. So I'll see you there. Bye bye.